right, thank you. Yes, like you said, my name is CosmWasm. I'm core engineer at Injective Labs, main contributor to the Injective blockchain. So welcome to Smart Contracts Unleashed, hyperscale development with Injective. So I hope if you take just one thing away from this whole day here is that Injective is the blockchain built for finance. That's the number one thing to remember. And what does it mean? It means eventually we want to replace all of the traditional finance world with decentralized technology. And well, I mean, we can't have all of the traditional finance world is obviously a vast way of different financial assets and products. And while we have some of the core financial products on chain, as Eric already mentioned, it would be impossible to have all of the traditional finance world built into the core functionality of the chain. So this is where you come in and you can join the financial revolution. You can build the next $1 billion decentralized application deployed on Injective and basically make this a reality. So this is what this talk is all about, telling you how can you make this happen. So on Injective, we're basically like one big fusion between Injective and CosmWasm is what we're using for as our smart contract platform. And CosmWasm, for those who are not familiar, this is like a high-level conceptual explanation. It's just a module that chains can add into their own chain with Cosmos SDK. This module is the WasmD. It's called WasmD. And as soon as you enable it, then you have basically CosmWasm enabled on your chain. And if you're a developer, you would actually like just write your contract. This is typically done in a language like Rust. Theoretically, it could be done in other languages, but Rust is what would be used right now. And you take this Rust contract, you would compile it with the CosmWasm compiler, and you actually end up with a WASM file, so like a WebAssembly file, which is like basically bytecode. This bytecode is then taken, and you would upload it to the chain. Now, this is for those who might know the flow from Ethereum Solidity contracts. It's a little different because in CosmWasm, you actually have it as two separate steps where you first upload a contract and then the instantiation is a separate step. And that's actually better because you have less duplication. When in Ethereum, every time you upload a new contract, you have to upload the whole bytecode again. In CosmWasm, it's just one time, and then you can instantiate as many contracts as you want from it. And then inside the WASM module, when you actually have a contract, then the WasmD basically, when you call a contract, it spins up a virtual machine. In the case of CosmWasm, they actually use the Wasmer virtual machine, but this is a technical detail you don't actually need to know as if you're just developing your own smart contracts. And it spins up a WASM virtual machine that at the ends, and then WasmD parses all the results that might have happened in the chain there. On Injective, we're using the latest and greatest CosmWasm 2.0 in the next soon upcoming upgrade. So that means you actually can use like the new cool features from CosmWasm 2.0. They actually improve a lot their developer experience. So they have like improved error handling. They have improvements for the sub messages and a new message type. So yes, definitely like you can make use of the best latest tech on Injective. The first entry point is probably going to be CW-Injective if you want to get started on developing on Injective. And you can see there's two folders. We have contracts and packages. And if you want to check out contracts, it's like a bunch of example contracts. And the dummy contract that you can use that's just empty. And so it's like a really good way to get like some idea on how some of the stuff works, also that I'm going to show you a bit later. One of the example contracts is sort of like the old way to do it. One is the new way to do it. And then we have the packages with some like Rust packages, like Injective CosmWasm as the main one. There's a math library that has additional math functionality and our own FP decimal type for decimal representation of numbers. And Injective STD, which I'll mention what that is soon. But let's take a step back first and let's figure out like if you want to develop a smart contract or the next financial decentralized application on Injective, like what does the smart contract conceptually even need to be able to do? On the one hand, it needs to be able to figure out what's actually going on the chain, right, on Injective. And then it also somehow needs to be able to interact with the chain. I mean, if it's not doing anything, it's a pointless contract. So it needs to be able to figure out what's going on and write stuff. And then on the third thing, it might also need to have like some internal state where it like basically reads and writes to its own state. So in summary, right, you have in CosmWasm you have state, messages, and queries. Now the state is just basically the most straightforward one, where you just read and write to your own smart contract state. The messages, on the one hand, you can have the messages that are defined by the contract that other smart contracts or even users can call. But then you also have messages that the contract itself wants to send out. For example, create a spot market order on the exchange. And then you have queries. Also here, again, you have the queries that the contract defines for himself that other users or even other smart contracts can call. So you can think of this, if you know Solidity, that's like the view functions in Solidity. But you also have the smart contract that might want to query stuff that's going on the chain, right? You might want to query an order book, for example. And so this is also part of the required capabilities. So let's start with the most straightforward, which is state. So state, like nothing specific here, it's just a CosmWasm way of storing data. Because if you're just writing code in Rust, then all your variables that you're going to declare are actually in memory. So the Wasmer virtual machine spins up. If you have any variables there at the end of the execution, they're all deleted because the virtual machine is shut down. So all the variables there, they don't persist. But you might actually, I mean, quite often you want to actually persist some data in your smart contract over time. So you gotta have to find a special way to write to the blockchain state, right? This is like would be persistently stored on the Injective blockchain. And you would use CW storage plus for that, like a package. And this is the most simple example where you just use an item which is storing a single value. In this case, a uint32. And whenever you want to read it, you just use the .load functionality. When you want to save it, you use the .save functionality. And this would then basically read or write to the blockchain state. Now, this is the most simple example. As I said, item. There's also like a bunch more. If you want to like have a map or index map, there's a bunch more inside in CW storage plus. So that was the state. Let's get to messages. If you know I would say the biggest conceptual difference between Solidity and CosmWasm is the concept of not having reentrancy. So that's a huge issue in Solidity, reentrancy. So just as a reminder, what is reentrancy in Solidity? In Solidity, you have a message call to your contract, and then the contract starts executing your code, and then at some point you might call actually another contract. Now, this other contract quite often can be some completely unknown contract that is provided by the user even. So it could be an attacker, right? So you call this other unknown contract. This other unknown contract would execute its own code, and now in its own code, it can also call another contract. So it could actually call back the original contract, your original contract. So what then happens is you actually go back to your original contract, and now you're at the beginning again of the function. And you can see how this actually becomes sort of a loop, because you go to your contract, you execute again, you get to the point where you called this unknown contract, you call it again, and now this can become an infinite loop. So this is the issue of reentrancy and Solidity. Now, of course, if an infinite loop would eventually run out of gas in Ethereum, so the unknown contract or like an attacker would have some kind of like stop condition. For example, after 100 executions, you stop executing, and at that point, your contract was executed like 100 times, but not all the way to the end, right? But just sort of like in this intermediate state. And this can break a lot of assumptions when you're writing your contract, because you don't expect like 100 times your function to be called, but only up to this one state. And then eventually you continue the execution. You might even call another contract. And so this is the reentrancy and Solidity. Now, in contrast to that, in CosmWasm, there's no reentrancy. So if we have a message call, again, now the flow of execution is actually, you go all the way to the end. So, and then only at the very end, now you can call this unknown contract A. Of course, this unknown contract A can execute its own code and then call back again. But the difference now is, as you can see, we actually executed our function all the way until the very end. So you never have the situation where you're in this intermediate state, because you know your function is always going to be executed until the very end. And then, of course, you can also call another uncontract at the end if you want to. But this is the way how reentrancy is prevented in CosmWasm. Now, in CosmWasm contracts, you define 5 different entry points. Like entry points you can think of are basically how does your smart contract start executing any code. So I already mentioned the messages, right? Like it's just like in Solidity, right? You can send a message to a smart contract, which would then have your defined messages in the contract. Similarly for queries, you can define entry points for different queries. Then you have the instantiation, as I mentioned, and you typically you initialize the smart contract state with its initial values. Then you have a migrate for actually updating contracts, but I'll talk about that later. And you have replies, which are basically, if you remember from the slide before, you can only dispatch messages to other smart contracts or even chain messages at the very end. So, but sometimes you want to send a message and then actually continue execution when it's done. So this is where the entry point, the reply entry point is for. So you can actually wrap your message as a sub-message, and then you can read the response, you get a reply back, and that's what the reply entry point is for. So how does actually submitting messages look like? So this is the most simple form, a very common way. This is like calling another smart contract. So for that, you'd actually just use CosmWasm std, the standard library of CosmWasm, where you find the WASM message defined. You call a function, for example, here's just my function with your parameters, and you define which contract address to send it to. You convert it to JSON binary, and you pass the funds. Now, one difference with the funds is actually that, unlike in Ethereum, where you can only pass the native ETH currency, in CosmWasm, you can send any arbitrary number of funds along with a function call. And then at the very end, you just add that message to your response. Now, if you wanted to interact with the actual native injective chain functionality, one way to do it is sending a JSON message. And here you would use the injective CosmWasm package I was mentioning earlier. And you can use, for example, here we create a spot market order message. And this basically just creates the JSON message for you that you can submit. However, I do recommend you actually use the Stargate messages, or rather they just renamed it to any message, which I guess is actually a better name. And Stargate is not sending any messages, are not sending JSON. Instead, they're sending protobuf. Protobuf is natively supported by Cosmos chains, so this is already more in line with how Cosmos chains operate. And while JSON is human readable, we're talking now here about a smart contract communicating with the chain. So it's 2 programs communicating with each other. It doesn't actually have to be human readable. And there are a bunch of advantages for using this. One being it's more performant, but also it doesn't require any maintenance on our side because you're basically using the native functionality on the chain. So the old JSON way, I cannot guarantee that this is actually going to be maintained. So I do recommend you just use the Stargate way. So how do you use Stargate messages or any messages? So for that, you would actually use the Injective standard library, which contains the auto-generated Rust definitions for Stargate messages. And in this case here, we're including the exchange module. And then in the exchange module, we actually just encode our message, create spot market order, and then send it as a Cosmos message Stargate. And the type URL you also would find from the actual exchange, also from the Injective std. And in this case, the create spot market order is actually just defined from ourselves. And here it's just basically the struct message create spot market order from Injective std. Since we're here now on the exchange logic, one thing to know here is that on the exchange model, we actually use tick sizes. And this is something, if you're interacting with the exchange module, it's going to be quite common. For example, we have min quantity and min price tick sizes. And that means, for let's say, I mean, it's not a realistic example, but it's an easier to understand example, that if you have an ETH USDT market, you define your quantity in ETH, and if the min quantity tick size is 0.1, then you always have to round quantities to one decimal, so 0.1. So if you have like 1.11 ETH, you'd have to round it down to 1.1. And if you're dealing with quantities, you always have to round down. I mean, unless you have a very strange contract, but usually you would want to round down to ensure that your contract actually has enough funds, to fulfill the order that you're creating. On the other hand, if you're dealing with prices, it really depends on your contract, right? In this example, I'm rounding to the nearest tick size, but honestly, it depends on your use case. Sometimes it depends on if you're doing a buy or sell, in which direction you want to round. And you'll find these rounding functions to help you in the Injective math library. And then one other thing is you do have to send all of these values in string format. And we do also have this toProto-string if you're sending values to the exchange module. If you're curious about the technical details on why this is needed, you can find me later and ask me. All right, and with that, we get to queries. So queries are actually very straightforward. So as I said, a contract can define queries that are actually, its own queries. But now it can also query things like, in this case here, a spot market, and find, for example, like the min quantity or min price tick sizes, right, that I was mentioning earlier. And all this basically by market ID. Market ID is just a string. Right? And you would import the injective querier from Injective CosmWasm, and then just use this depth value that comes from CosmWasm, wrap it around, and you have all the queries that you can immediately use right there. And this is sort of like the old way, JSON query. Again, I actually recommend you use the new way with the Stargate/any queries. And it looks actually very much the same, except now you're importing from Injective STD, the exchange querier, but otherwise it stays the same. Although under the hood, what actually happens with the Stargate is, again, it's not sending JSON, it's sending protobuf. So you can also send, if you look at the second line request, you can also send this in the raw format, but you kind of don't need to do all of this because from the exchange query before, this is all nicely abstracted away for you. All right, so let's get to some common questions. One is, how do you update smart contracts? And if we think back, maybe from the Ethereum world, technically speaking, in Ethereum, these smart contracts are all immutable. But people, of course, realized quickly that in real life, you kind of do want to update your contracts from time to time. And immutability, while it's a nice feature, it's quite often not what you really want. And in CosmWasm, in the Ethereum world, they built basically a hack around with proxy contracts around this. So unfortunately, in CosmWasm, there's no need for this because updates are supported natively by CosmWasm. But they are optional. So when you create your contract, there's an admin field that you can define, but you don't have to define it. So if you don't define it, it's an immutable contract, because sometimes you want immutable contracts. But if you do define an address, this address is allowed to migrate the contract. And migrating the contract in the most simple form is actually pretty simple. You just upload a new bytecode, and then you migrate that contract to the new bytecode. That's it. Now, sometimes this is not enough, because you might change the state, right, in your contract. And when you change the state, definitions, you remove or you add new variables, you need to initialize these new variables. And in that case, this is the migrate entry point I was mentioning earlier. You have to, in there, then basically initialize the new state that you added. But that's pretty much also it. So not too complicated, because migrations are a lot easier than in Ethereum world. All right, next common question: how do you test smart contracts? You can test smart contracts because it's in Rust. Of course, you can write Rust unit tests, and this is the first line of defense. You definitely just write some basic Rust unit tests. But this is, of course, we're living in a complex blockchain world. This is not really sufficient if you want to have proper testing, and especially also with interacting with the chain. So what do? Well, for one, there's a package called, or repository called CW Multitest. And what that allows you is to mock the responses from queries or messages to other contracts. So this works. We also have support for this inside CW Injective. We have an Exchange mock querier where you can basically mock all the queries that might come to the Exchange or Injective testing package with some additional mocking helpers. But for the most part, I actually recommend you don't go down this path and instead use a test tube. Now, test tube is a way to run like full blockchain locally on your computer. I mean, the cool thing is it's not actually a full blockchain. It's not creating blocks or anything like that, but it's just calling natively into the chain logic. So it's like just a minimum amount of what you actually need, like running the chain logic, without the overhead of actually running a full blockchain. And this allows you to still live in sort of the Rust world. Actually, let's take a look how this would work. So you would import Injective test tube in your Rust code. You just create a new app. You can initialize some new accounts. And then you typically, at the very end, you would read your WASM file. So your contract compiles to WASM, read it from the disk, and then upload it. So there you can see maybe also the bit of the pros and cons of this approach. One con of this approach is that you do have to compile your whole contract into WASM first because, well, it's like a full integration test in a sense. And that also means you're leaving, even though this is Rust code, you're kind of leaving the Rust world because then you're executing the WASM part right of your contract in the WASM world. So that means if you have any print lines in your contract, where you can't debug into it, right, as well as with the CW multitest. But in my opinion, it's worth the effort because we've gone down both paths, and it's mocking the responses and whatnot. It's just a lot more of a pain for the small inconvenience of having to first just compile your contracts into WASM and then running the test. And also, you can actually you can print line with deps.api.debug. So it is possible to add some debugging info even in this kind of testing. And I did actually hear from one guy another tool, CW Orchestrator, today, which I'm going to have to look into. But that's also an additional tool that can be integrated with TestTube or CW Multitest, which sounded pretty cool. And you can even test it against like a live network, like the mainnet, for example. So yeah, I actually have to look into this myself, but this is also a tool basically on top of all of this, CW Orchestrator. And and the cool thing is with TestTube, you can quite easily, for example, create a spot limit order. So you could write some helper functions to basically fill up the whole order book and simulate like quite easily a real life trading environment. So yeah, this is relatively easy to use. Now another question is, can a contract transfer derivative positions? Now, for normal people to transfer derivative positions, would be a security issue. So it's of course not allowed. But in the contract world, we can actually allow this because presumably if a user calls a contract, it trusts the contract. So in that case, we can actually allow the contract to transfer this. But since this is sort of like not a normal flow, we had to add like a new way to do this, which is called message privileged execute contract. So when you call it this function instead of the regular message execute contract, the contract has additional basically privileges. Now I did mention position transfer. Synthetic trade is, I don't have too much time to get into it, but it's effectively like doing a synthetic trade. And position transfer, one example how this looks like is you can transfer from a source sub-account to a destination sub-account. But of course, these sub-accounts, they actually have to match the contract and the user who's calling it. And we do use one special feature here, which is the .set data. So then in CosmWasm, you can like add like arbitrary data to a response. And then on the chain side, we're passing this data. So this is like quite a unique way that you might have not seen too often. But in this case, you have to do the .set data. And yes, if you want to look more deeply into like how to use TestTube on Injective, how the financial logic works, this is a really great point to get to look into, like the swap contract. The swap contract is a tool or contract we have that allows to do hops over an arbitrary amount of markets in a single transaction. So there's quite a bit of the financial logic involved, and we use TestTube as well for a lot of the testing. So if you want to look into that one, is a good repository. Now, quickly for tools and ecosystem. Now, of course, interoperability is at our core at Injective, and that also applies to smart contracts. So you can, of course, use IBC. This is natively supported with CosmWasm. That IBC, you can send and receive IBC messages. We also have support for IBC hooks, which is a way to transfer tokens and then also call a smart contract. We have Wormhole, that Wormhole way also to bridge or send messages between different chains, which also works with CosmWasm. If you want to automate your contract, we do have on Injective, we have Warp protocol. So we also have a second way to automate, which is the WasmX module. And so it depends on, I would say, if you want your automation to be extremely robust and you don't mind it to be a bit more expensive, you can use the native WasmX module. And otherwise, you can use the Warp protocol, which is like an automation tool that just calls the contract depending on the conditions that you define. And if you want to use a RPC point, like in Fuhrer for Ethereum, I encourage you to check out New Metric, still in beta, but a very cool project. And if you need randomness, we do have noise network on our chain working, and you can get random values from noise network in a verified way. And lastly, of course, you can check out the Injective docs, and especially like if you're a developer and you care about the technical details, you can check out the modules section, Injective, and then dive deeper into how all these modules work and what messages are available. And with that, we do have Discord, Telegram, and the QR code is actually the one that you see everywhere. This is specifically for developer Telegram. Thank you very much.